Come on, girls. All right, we're just gonna give it a couple minutes, girls, just to make sure everybody's up and running. All right, girls, if you can hear me, we're having an issue here because I think I've got two of these.
What's the problem?
We got two meetings right now. I don't know how it happened, so I'm going to cancel you out of this one, and we're going to try and join the other one. Okay?
Yeah. Oh no.
No, that didn't work. Okay. Good morning. I'm having an issue here. Somehow two meetings got started up this morning, so I'm going to have everybody come off of this meeting right now, and I'm going to start a new meeting for 9:05, okay? So just hang up right now, and I'll start a new meeting for 9:05.
Okay.
All right. Okay. That's better.
Good morning.
Morning. Sorry about that. That was a mess up on my behalf this morning. Technology didn't want to be my friend this morning. Okay. Right on. Okay, so good morning, everybody. I'm going to, I want to do a better job of explaining something I didn't do a very good job of explaining yesterday. And I'm going to show you, I'm going to go through that example 2, and then I'll go through example 3. But what I want to do is, I didn't explain this real great yesterday in terms of the cases and what's happening. So there's 2 scenarios that can occur. The first scenario is if that 3x plus 2 is greater than or equal to 0, meaning it's a positive number or 0, okay? And if 3x plus 2 is less than 0. So there must be some sort of domain that will work for the x value. And so what we want to do is we want to narrow it down. So each time I do this, I'm going to run it as 3x plus 2 is greater than or equal to 0, and then 3x plus 2 is less than 0. So I solve for this, and I get x is greater than or equal to negative 2/3. So my answer would have to be x is greater than or equal to negative 2/3, or x is less than negative 2/3. So basically what we're saying is, in this case, is it would have to fall into one of those 2 categories. Well, this one takes care of all of them. But all it's stating is that we're going to have a possibility of extraneous roots. One root may not work. It may not fit into what we're looking at on this domain here. Okay? So what I do is I start with this, and then I solve it. So I do my 3x plus 2 equals 4x plus 5. And then I do 3x plus 2 is equal to negative 4x plus 5. Okay, so in this one, I solve, I move the x over, I move the 5 over. That gives me negative 3 is equal to x. All right, so if my x is equal to negative 3 here, is negative 3 greater than negative 2/3? The answer is no, it's not. So it can't work. So that's what we consider an extraneous root. So I check it for the positive and the negative, and then I cross it out if it doesn't work. Now when I solve this guy, I get 3x plus 2 is equal to negative 4x, subtract 5. Negative 7x is equal to negative 7. X is equal to, is it negative 7 or plus 7? No, it's plus 7 here. Sorry. Messed this up yesterday and again this morning. A bit better. So then x is equal to negative 1. Is negative 1 less than negative 2/3? The answer is yes. So for each case, I'm checking my solution to make sure it satisfies the inequality that I have here. So in this case, I had x is greater than or equal to negative 2/3. X was not in this case, therefore it's an extraneous root. In this case here, I have x is less than negative 2/3. X was equal to negative 1. That is less than negative 2/3. So therefore it works. So this is the only solution that I have for this. So I probably confused you a fair bit yesterday in working through these 2 case things. All right, so I didn't like the way I left that off. So I thought today I would go back and explain it. So the first case is always where you have greater than or equal to 0. The second case is where you have less than the 0 value, okay? And I solve it the same way. All right? So I'm going to have a look here. Let's have a look at that example 3 now in your book. Check and make sure everything's good here. Okay. Now, so I have x squared minus 6x is equal to 8. Okay? So absolute value, x squared minus 6x, absolute value is equal to 8. So now we're going to get into a bit more work when it comes to this. So it says use the definition of absolute values or value to determine the cases here. Okay. I don't know if that cuts up me off or not, but lost connection. Okay, so I have x squared minus 6x is greater than or equal to 0. And then I have x squared minus 6x is less than 0. So there's our two cases. So let's do that first. So case 1. So I have x squared minus 6x, okay, is greater than or equal to 0. Therefore, if I factor this, that means that x is greater than or equal to 0, or x is greater than or equal to 6. So those are my two here. Okay, and then over here, I've got x minus 6, less than 0, x is less than 0, x is less than 6. All right, so my domain now, when I solve the question, has to fall somewhere in between those two. So if x is less than or equal to 0, or x is greater than or equal to 6. Okay, so now, I'm going to do this. This is what I mean. It's a fair bit of work. I'll come back to this page. Now what I want to do is go x squared minus 6x equals 8. X squared minus 6x is equal to negative 8. So now, again, it's working with quadratics. Get it equal to 0. X squared minus 6x minus 8 equals 0. X squared minus 6x plus 8 equals 0. This guy here is factorable. X minus 4, x minus 2 equals 0. X is equal to 4 and 2. So that one's pretty straightforward. That's easy enough. All right. The one over here is not factorable. So now I have a decision to make. Complete the square, graph it, quadratic equation. And to me, it doesn't matter which. I like, again, I'm probably choosing to complete the square here. And the reason I'm choosing to complete the square is because it's actually fairly quick. So brackets, x squared minus 6x plus 3 squared minus 8 minus 9 equals 0. X minus 3 squared is minus 17 equals 0. X minus 3 squared is equal to 17. X is equal to 3 plus minus the root of 17. So again, at that point, I would leave it. I leave it like that. So now you would have to check your roots, your rooted values. Okay, so I would check to see, okay, so this I'm probably wanting an actual number for now. So I'm going to go 3 add root 17. So 7.123. And then 3 subtract root 17. So I end up with that. Now I have to check my solutions with my, and I'm sorry, this is small. So my value had to be between 0 and 6, or greater than 0 and greater than 6. So in this case, I believe both of them work actually for this one. Just follow through. Yeah, I think they both work here. X squared minus 6x if x is greater than, or sorry, less than or equal to 0. I don't know if that's a misprint or not for that one. I feel like I'm missing something here, so just give me 1 second. Okay. So 3 of these solutions work. So the solutions are, so if we substitute them back in, we could do that. That might be our best bet here. So let's do that. I'm going to substitute them back into my original equation. So my original equation is x squared minus 6x equals 8. So I'm going to punch those values in. So 7.123 squared minus 6 times 7.123 equals 8. So this one works. Now I'm going to go negative 1.123 squared. Subtract 6 times negative, negative 1.123. And I get 5.4. So this guy does not work. Okay, he was also not greater than 0, so we could have figured that out. And then over here, I'm going to put in, so this is 4 squared, which is 16, 16, oh, sorry, we're back. And then 12 is again negative 8. They both work. So your solutions for all of this is that there. Okay. All right. So we still need to hammer this out a little bit more. This and this. Okay, because I still think there's something missing there. All right. That's about it for that. Let's take a look at the last example here. So I've got absolute value. So I have the absolute value of x squared subtract 1. And it says determine okay. What I'm going to do, I think I need to do to explain this a little bit better. All right, I'm going to draw this first because I don't like the way I'm doing this. So I'm going to draw it and go like this. Okay, so x squared subtract 1. This is going to help to make more sense of that that part where we're doing that split x squared minus 1 if x is greater than or equal to or x is less than or equal to. I'm going to do a better job of it here. So let's go like this. There's x squared subtract 1. Whoops, it's a problem. My bad. So x squared subtract 1 looks like this and like this. Okay, so that's y equals x squared subtract 1. And then I flip this up and I have here. So judging by just the graph, this part here and this part here is when y is greater than or equal to 0. So that means that case 1 for x squared subtract 1 being greater than or equal to 0 occurs when x is less than or equal to negative 1 or x is greater than or equal to 1. That's what I should have done in the last question. So my zeros right here occur in the positive when x is less than or equal to negative 1 or x is greater than or equal to negative 1. Case 2, where x squared minus 1 is less than 0, occurs between these 2 points. So that is -1 less than x less than 1. So if you're following through in your workbook, which I would like you to do, you have x squared subtract 1 if x is less than or equal to -1, or x is greater than or equal to 1, and negative x squared subtract 1 if it's between -1 and 1. So we can write those out. So now I want to solve. So I've got these already in place. Now I'm going to go back a page and I'm going to solve this. So x squared minus 1 equals x. X squared minus 1 equals negative x. X squared minus x minus 1 equals 0. X squared plus x, excuse me, minus 1 is equal to 0. So again, we're at that junction point. All right, we've got to solve for these using one of our 4 methods. So I either got to use, I can't factor them, so I can't use that method. So it's down to 3 methods. Quadratic formula, the graphing, okay, that's also, and then the completing the square. So this time I'm going to use the quadratic equation because it's not, it would be into fractions otherwise. So I've got A, B, and C. A is 1, B is -1, C is -1. So let's plug that into our formula. So x is equal to negative b, which would give me 1 plus minus 1 squared subtract 4 times 1 times -1 all over 2 times 1. 1 plus minus the square root of 5 over 2. So at this point again, I'm going to put that into, I'm going to use my calculator to solve that because I need to find out whether or not it fits. So when I add them, I get 1.618. When I subtract them, I get negative 0.618. Okay, so just looking at my 2 solutions, the first solution is 1.618, and the second solution is negative 0.618. So in order for these to work, okay, this is where it gets tricky. In order for these to work, they have to satisfy this. So they either have, the value has to be less than -1 or greater than 1. Well, this one's greater than 1, the 1.618, it works. The negative 0.618 does not work. So I'll make that bigger. So 1.618 works. Negative 0.618 does not work for it. So that's for case 1. Okay, so case 2, have to do the same thing. A is 1, B is 1, C is -1. So I'm going to end up actually very similar. So now I'm going to have -1 plus minus, it's going to work out to the square root of 5 over 2. Okay, so I've got same thing I had in the first one. So in this one, I get 0.618. And in the second one, I get negative 1.618. Okay, and so these two have to fall between -1 and 1. If they're outside of it, they don't count. So do they fall between -1 and 1? This one does, this one does not. So the only two solutions are for this entire question are that and that. All right. So it's going to take you a little bit of work to get used to it in terms of the quadratic part of this. Okay. So I'll leave this on here for a sec. So the quadratic part is the part that's going to cause you grief in terms of my case studies. Okay. And how the cases work. The linear ones are fairly straightforward. All right. So what I'm going to do is I'm going to have a look at 2B on page 303 this morning, just to get you going, just to have it make sense. And we'll go through each of the steps of the process to make it work. Okay? All right. So in 2B, I have 9 equals absolute value of x plus 3. So the first thing I want to do is check case 1. Case 1 is when x plus 3 is greater than or equal to 0. Case 2, x plus 3 is less than 0. So in order for it to work, x has to be greater than or equal to negative 3, or x has to be less than negative 3. So for the positive case, I go x plus 3 equals 9. Okay? Subtract 3 from both sides. X is equal to 6. Is 6 greater than or equal to negative 3? Yeah. That's the correct answer. All right. Let's work over here now. X plus 3 is equal to negative 9. X is equal to negative 12. Is negative 12 less than negative 3? Yeah. Also works. Now you could substitute them back in. 6 plus 3 is 9. The absolute value of 9 is equal to 9. So obviously it works. In this one, negative 12 goes in. Negative 12 plus 3 is 9. Negative 9 again, sorry. And the absolute value of negative 9 is 9. So it works for both. They do ask you to solve it by graphing. So let's solve it by graphing. Okay? So the first thing I'm going to do is graph x plus 3. All right? I want the absolute value of x plus 3. So I'm going to go to 1, 2, 3, 0, 3, up 1, right 1. Looks like this. And my graph is going to look like this. Here. And then back up that way. This coordinate right here will be negative 3 and 0. All right, so this is the graph of y1, which is the absolute value of x plus 3. All right, again, you can use your calculator if necessary for it. The second graph I want is that one, where y2 is equal to 9. Then I find out where their intersection points are, their intersection coordinates. All right? So this is going to be negative 12 and 9. And this guy right here is going to be 6 and 9. All right, and again, you have the use of your calculator if necessary. right. Okay. So that's basically all I have for you today. That's new. So I'm going to give you a little bit of time this morning, first of all, to ask questions. So if you have questions, whether it's from 7.2 or 7.3, if you started, let's go through those right now. I need one.
Do you know when we'll be going over our assignment?
You know what, Amber, I'm going to likely mark those today. That's my plan. And if I get them marked today, I will go over them tomorrow morning with you.
Okay, sweet.
Okay, so I'm hoping to get them marked today. I think I got them almost all in. So that will be, yeah. Okay, so the assignment we'll go over tomorrow morning to answer your question. Anybody have any questions from 7.2 or 7.3 this morning? None yet? Okay, again, I'm going to leave this forum open. If you want to visit, by all means, if you want to do some work and talk it over, great. I'll stay on here to listen. So just be aware of that. I'm on here still. And if you have questions, but let's leave this open for another 20 minutes. I'll shut down the YouTube right now. And yeah, let's go to work on 7.3 on page 303 if you've completed 7.2. Okay? So I'm just going to mute myself until I have a question.